This is a demonstration of the Grasshopper Tekla link, and the link is the set of components that you see here up in the Grasshopper ribbon under the Tekla tab. And these components can be used to connect the output of the Grasshopper components to Tekla structures. So the example here is a building frame, which is here defined using standard Grasshopper components, and the parameters are collected here on the sliders on the left. And the definition here produces the output that you see here in Rhino, so if I change the parameters, the model will change in Rhino as well. Just standard Grasshopper behavior. And we're now going to replace Rhino with Tekla structures. So let me move that one away, and we start here with an empty model in Tekla structures. So now I can use the point component here to see where we begin. So we first have our starting points here in the Y direction, and those we copy in X direction to get the second set of points over here. And now between each pair of points here we can create a beam in Tekla structures using the beam component. So I insert that component, connect the line here, and there we have beams between each of those components. And now as I control the sliders here, you can see that it updates the beam in real time in Tekla structures. And now we continue this process by inserting points here between the start and end points of the beam, as you can see here. And then we copy those points in the Y direction to get the three-dimensional grid here of points. And we can insert beams here now in the other direction as well, and these beams that you see here will become then the support beams of the slabs in this frame. So let's go ahead and create the slabs next, and for that we have here the Grasshopper rectangle component, which is using the same input here that is defined by the parameters. And we can use then the rectangles that are generated to create our slabs. So we just connect the output there to the slab component, and here we have now the slabs in Tekla structures. And if we want to enlarge the slabs a bit, we can use the offset component, and let's use a slider to parametrically control then the offset. And let's reconnect here, and now we can control the offset of the slabs. And finally let's throw in then the columns. We have here the output which goes from the bottom slab to the top slab, and using the column component then we get columns. And we can also throw in a grid then. Let's use these points, and the grid will then be generated. So now we have our frame here, which we can control with the parameters we have. So just like in Rhino, it will update the model here in Tekla structures as we move the sliders we have here. So we can add columns and remove columns. We can control the floor height or the number of floors, of course. And we can also then set the attributes of the individual components, or sorry, the individual parts here in Tekla structures. So let's try with the columns here. First we can set the position of the column. I see it moves around nicely. We can set the common attributes like the class. And we can also, for example, rotate the columns using a control knob. let's set this one to degrees and connect that to our position component. And now the columns can be rotated here in Tekla structures. Then we can set the profile using the profile component. And here we open the Tekla profile catalog and let's pick something. This is probably a good profile. And it's updated here in Tekla. Or then we can create a parametric profile here on the fly. So again, let's use a slider, and we can then connect that to this string component. So we have width times length, for example, and connect the slider here, and as a result we get a string which can then be used as the profile for the beams. So let's connect that to the component, and now we can parametrically change here the width of the columns. And of course we can do the same for the slab profile to control the thickness of the slabs.